Yo, 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 what's up, what's up? We're back after a couple of days break, at the least. What's up, Coolers K? We're gonna continue and hopefully finish the first iteration of the creature variation graph implementation we've been working with. It's been quite an adventure so far, learning the graph toolkit of Unity. It's experimental, bare bones, but it's very simple and does its job. And we're just gonna jump right into it where we left off. And we're in the process of implementing this graph, which is used to generate the visuals of our first creature called Sten. It's a very simple creature. It has a type of base mesh, and then we randomize a number of eyes on it. Or at least it sounds simple, but it's pretty... You want the stuff to be generated randomly the correct way, so to speak. But we have a few nodes left to implement here, and then we have one of the biggest or one of the hardest things that are left to implement, and that's the repeatable nodes. So basically, the right side we see here, we want this to repeat a number of times, a random number of times actually. And I think the approach we're going to take to that is to have a node here, and everything that is connected to that node up to a point is repeated X times. But okay, let's see, where were we? We were in the process of implementing dynamic mesh to polygons runtime node. Yeah, I think it's this one. So the idea is that when we want to get a random transform on dynamic mesh, we will be able to get it by polygon or by triangle, or maybe we even can take a vertex. In the case of Sten, we want it to be polygons. So let's see if we can finish the implementation of this one. I'm not entirely sure what's left actually. Maybe we even finished it last Friday, I want to say, or Thursday. Okay, so we have the dynamic mesh to polygons editor node here. We had to implement this one polygon list because we want the list to be serialized the correct way. It's very basic. We can probably add this one soon, but okay. So we have option here, which is an angle threshold internal name. It's just a float, I mean. And we have an input port, which is a dynamic mesh, and we have an output port, which is a polygon list. So that's a list of polygons. Okay. Okay, I think this one looks pretty good. Let's take a quick look if we can add it here. Actually, one more thing. This is another node we would like to repeat a set of times. Fuck, I'm not entirely sure how I want to solve this. Because when we have a set of nodes we want to repeat X times, we want to split it at this side and this side, and then internally. Like in this case, I would like to only repeat this one. Maybe we can send in another node. But yeah, do we want to make a node that takes... a node as input and output? I will see, we'll think about it. But anyway, we had dynamic mesh to polygons. Here we have it. We can set the angle threshold. We have dynamic mesh input, polygon list output. Okay. So let's do this then. I want to skip. This is dynamic mesh to bounds. Okay. I want to skip. Let's remove this one for now. And these. And then we have dynamic mesh to polygons editor node. We want to take this dynamic mesh. And we get a polygon list here. Let's take a quick look at the runtime node of this one. Take dynamic mesh as input and returns a polygon list as output. Polygon list. Yeah. Generate output, we just get a dynamic mesh if we can. And then we do get polygons with angle threshold degrees here. And then we set it in the cache. Okay. Dynamic. Okay, this one seems to be implemented. That's great. So now we can focus on this one, random transform on dynamic mesh. But fucking hell. Dynamic mesh to polygons. Maybe we could have done this in here and saved ourselves some headache. Well, the thing is, no. We want to save. We want this one to be cached. Okay, let's do it like this. So, random transform. Yeah, we're gonna do a random transform node, and this one is gonna have a lot of settings. One of which is going to be what input we want. Dynamic mesh to polygons, dynamic mesh to transform node. So it's actually not going to be a dynamic mesh to transform node. I think we're going to take the random node. Okay, let's do this. The random node is going to be... yeah, it's going to be a big node, I think. Random value. Yes, okay, so we have an option here. Let's take a look at random value. we can output int, float, vector2, vector3, and transform. It's not really implemented just yet. I would like the input port to be dynamic, so we should be able to connect anything there. I'm not entirely sure this is doable just yet. This one. So instead we're going to add an option here where we have input type, and we are gonna change the input ports depending on what input we choose. Random node is probably gonna be extended and developed a lot of times. We're gonna iterate through it a lot of times. So let's do random. Yeah, I want to rename this one. Random editor node. And random runtime node. And then we do, let's just copy these. Or we're gonna name it and here I want to do polygon list, I think. Okay, and for all of these, we're gonna add some additional stuff. Let's see here. Can we make this? Could we do? I wonder if we could do something like this. Let's see. Could probably have done this with type, maybe. Let's see if this works first of all. What is it? Is it system? Okay. Missing node. Okay, so if this works, we can clean it up a bit as well. We need it at compile time, don't we? So we can probably not do type here, right? Yeah, so let's skip that. Actually, I want these. Let's do it like this instead, with a lot of code. Lower bound. See how this looks. Yeah, we want to change it to output, but other than that, okay. Okay, beautiful. And then we're gonna add additional output type. Maybe additional output type. Default value none. What I want to be able to do is, I guess we're gonna take yeah, it's probably gonna suck to implement this runtime version. Not entirely sure. So if here we want to polygon list. Maybe we should do display name. Maybe it should be this one instead. So this means that we're gonna have to implement this for every case in output type. I think I'm okay with that. And I'm not entirely sure what that means now. So additional input polygon list. I know what this means for transform, that we just want to get a random transform. But if we have a polygon list input, we want to get the random transform based on that polygon list. Random int for with a polygon, I have no idea. Maybe we can show some information when an input is set that isn't really that useful, you know? Or not implemented. But so when we want to generate some random eyes for our Sten creature, we want to get all the polygons from the dynamic mesh, and then we want to get a random transform on it to be able to place that eye on the stone, pretty much. So for us, it's going to look like transform polygon list, like this. Lower bound value, upper bound value. I wonder if yeah, you know what? If we have some input, we probably want to remove these. Maybe. Or if it's equal to none. How did I manage to screw this up? Oh, yeah. I put it in the wrong. Let's do... this instead. Transform is component, right? So I think when we don't have any input here, we should skip these two for transform, I reckon. Or actually, yeah, it's gonna be... When we have transform, we want lower bound for position. And we can't really return transform, right? No, we can't. We're gonna have to add an additional data structure, I think. It's gonna be transform data or something like that. Because if I don't misremembering stuff, let's see here. Transform. Inherits from component, yes. So we could have int float vector 2 vector 3 transform content maybe, which would probably be a vector 3 position, vector 3 scale, and a quaternion rotation. We have nodes. Where do I want to put this? Node system. It's almost like I want to put polygon list there as well, but generation dynamic mesh, primitive, lists, primitives. Probably gonna move this one later on. I think we will be using this one when we are saving and loading data as well. But for now, let's put it graph. Yeah, that's fine. I think we need to serialize it, but we'll keep that in mind. So then for our random editor node, we want to change transform. Yo, what's up, Derek? We want to change this one from a transform to, what is it? Transform data. We're gonna have to fix the dynamic mesh implementation of that one. That's okay. But But you know what? Yeah. Let's see if we can start implementing this one. Oh, we want to add a lot of rules and stuff like that as well. And okay, let's see random runtime node. We don't want a prefab. Input count. Yes. Yeah, this is, let's see here. Yeah, we're gonna have to add a lot of custom classes here, I think. Input and output count is gonna be decided in the constructor, so that should be okay. Runtime node, no. Random runtime node is compatible with connection. Yeah, this one we're gonna have to check. Okay, this one is gonna be our one of, if not the most complicated runtime node to implement. And then of course I don't count dynamic mesh slicer runtime because the logic, the actual slice was already implemented. But this one, it's going to be a lot of ifs and else here, depending on what kind of setup we have, or might not be entirely true, actually. We could also, let's see here, I have a class called range, which I probably want to change into a T here. We want this one to work with a lot of different classes, or types, I mean. But if it does, And that might be a separate issue, actually. That's going to be quite a heavy rework, I think. System serializable, but this one could absolutely be used with so if we take a look at our random editor node, let's fix this first. So I want to convert lower and upper bounds. Fucking hell, maybe we want to make them into range instead. What I'm getting at here is so either we have it like this and we define lower and upper bound and then we convert it to a range at some point. I don't really know. Range with transform, yeah. Or can we have range with vector 3? I think we can, can't we? This one we can't implement. Vector, where do we use this one? Nowhere. Okay. We have range vector here. Yeah, we have some more functionality. Okay, maybe, just maybe, we can wait with this. I'm gonna write it up in my very big notepad file. I want to put it as a maybe. Maybe improve range to be range T for generic type. Makes sense. If so, rework random node. Okay, so for now, we're gonna maybe do double the work, but yeah, that's okay. We're gonna have some custom structs here, and when we convert our random editor node to a random runtime node, that's when we're gonna create one of those structs and send in as a to the constructor of the runtime node. Much like we do in, I think we do it. Yeah, we do it here. So much like we do in dynamic mesh generator editor node. So when we convert it to a runtime node, we build these setup structs. Dynamic mesh generator runtime node setup. So we're gonna have something very similar in our random runtime node. A struct that describes how we want to generate the random value. Yo, what's up, Spires? Thank you for the raid. Appreciate it, and you too. Yo, what's up, Cooler SK? Over on this stream, we're still working with the Unity Graph Toolkit, but I think it's going pretty good, actually. Trying to implement a random node, which is gonna be able to generate a lot of random values based on a rule set. But how should random runtime node, how should we structure this setup here, is my question. So for now, it's pretty basic. If we choose float as output type, we input a lower bound float value and an upper bound float value. And then we probably just do a random range. If we choose transform and polygon list as input, then we want to, then it's a lot. So what we want to do then is we want to get the polygon list, we want to get a random polygon, and then we want to calculate a random transform on that polygon, right? Yo, what's up, GDs? I guess we could do it as a big switch case as well. Or maybe we could make this one into yeah, we could. We could make this one into random runtime node T. But that's going to be complicated. If we want to do random value int, yeah, we're going to need to know this. Okay, let's do it like this. Random runtime node. Public class. Public abstract class. Generator. And then we have public class. Yeah, let's do int generator. Float generator. And when we generate output, it's actually T, so that's fine. That's fine. Okay, this might work. And finally, transform data generator. Yeah, let's do it like this. Int I'm still not entirely sure how I want to do the polygon list stuff, unfortunately, but we will get to it. Yeah, let's start without the polygon list, see how it looks. We're going to remove these from here. And then we're going to do public abstract T. I would have hoped. We probably can't use the same T. Can we do... We can probably do it like this. Bool generate ref t value. Doing it like this will probably work better here. Let's do it like this. Let's try, see what we get. So generate return math, or actually random dot range. Unit engine, okay, good. Eventually, we're also gonna have to can I do it like this? Oh, we don't want to do it here. Ooh, yeah, we do, but we want to change this one to override. Can we do max exclusive? Or you know what? Maybe. Yeah, don't we want to do it like this? Oh, I have something exactly similar to this. Where do we have it? It's terrain, data, buffer container. Don't we have it here? Yes, maybe, just maybe. How can we structure this? I would love to do something like this. Or have it like this, and but then we're gonna have to do one sec, be right back. Okay, back. Could we do something like this? It would be beautiful. Problem is, I want to do very specific stuff depending on what the type is. Right. What's up, No Bro Studio? Public abstract T generate. Like this. Appreciate it. I think this will do. And then we have, this one is weirder though. But also, okay, now we're not taking the transform data into account at all. So later on, now we will just implement the most basic cases here. Ooh, a little bit worried about this one, maybe. Game creatures generation graph. I thought we had this one here. Editor. Game. There we go. Why does it keep... let's see, in Nobro Studio, you can also put the min-max in the abstract class, right? As each generator is using it as OT min-max. Oh, beautiful. Appreciate it. That's true, that's true. Yo, what's up, Maori? That is true. I'm good, I'm good. How about you? Yeah, let's. Float, vector 2, vector 3, and transform data. And we want to make these, oops. Inclusive. Okay. This one. We're just going to implement them as randomizing each component this time around, I think. Let's return new vector 2. And then this one. Transform data, position, rotation, scale. You can probably get random return in some way. We'll see. Nobro Studio, I use a similar variable class for random generation and author generation of values. Oh, nice. It looks pretty simple right now, but I think this will grow a lot. Nobro Studio, I use a delegate with a set value function. Okay. Yeah, let's generate this one. Return new transform data. And then I guess we're gonna do this, and we need to define yeah, we're gonna get to this one eventually. I want to do the scale first. Now we have quaternion. I have no idea how I want to solve this one. Do we have... rotation? Beautiful, but we want to do it... We want to do it based on bounds. That's a bit more complicated, I reckon, but one have to think, what does it actually mean? So I think we're just gonna do we are gonna do quaternion lerp min dot rotation max dot rotation random value. Oops. No, I mean, we define what it means, and so if we have two rotations and we just pick a random rotation lerped between those two, I think that will be okay for our use case. Truth be told, I don't have a use case for random transform based on no input data yet. Yeah, no, Bro Studio, we have no Euler angles yet. We basically just have a quaternion min and a quaternion max. Okay, let's roll with this one for now. And we want to add a little bit of a return here. Okay, so that's our base random generators for random runtime node. So I think we can do something like this then. Or actually, we're gonna do random runtime node. We want to have a setup here, which is gonna be private generator. Even, I guess, generator. Or do we need... Can we do... Using generator, yeah. So what is the issue here? Or do we need to specify it here? Because if that's the case, then it sucks. unfortunately. Mm. Hmm. Yeah. Okay, we want to work around this. We definitely do. So how can we redefine it to make it work with this? We want to have a generator here. We want it to be opaque. Um, uh, mm, yeah, we have a few different plan of attacks here. This is very beautiful though. I would like to have something similar to this, but we will need to alter it a tiny bit. But the thing is, we might as well make it such that it works better with this. So we skip this, or actually we skip this and this, and we do something similar to this. That would work, right? So if we do, let's just see if it works first. So let's leave our int only, and then we remove this, we move these back, we define them here as ints, we remove this one, and then we change this one to be this, and fuck, we're gonna have to cast it right, aren't we? Because we can't do this, although I would love to. But we can do this, and it would be beautiful to be able to do this. But then we're gonna have to do this. I mean, it's not pretty, but we're probably gonna have to do it here either way. That's basically what we do. If we check dynamic mesh generator, um, generate. Yeah, that's pretty much what we do here anyway. Don't we? Yeah, here. The object generate. So the only thing is we're not going to need to do it in generate output. Instead, we do it here. So if we have it like this, then we can keep it like this. I mean, let's. Then we don't need protected either. Okay, that's more than I want. Oops. Okay, because if we do it like this, then we can send in a generator here. And this generator is equal to generator, and then in generate output, we can just do values equal to generator dot generate p like this. We should never I mean, we could get an error here. Yeah, I probably want to make a check here. Right. We could add a check here. I'm talking about this. We do something like this. If type of t actually, we don't want to do if, we just want to return this, right? Int float 2. So then we do if generator can public abstract, let's put it an output bool. something like that. So we do generator dot can output t value. If it can't, then we can't generate the output, so false. Otherwise, we generate it, put it in the cache, and return it. Okay. So then I guess it's time to create these generators. I don't know if it's a good idea to let the editor node do it. Probably. Yeah. So to runtime node, the first thing we want to do is to generate these, or to instantiate these generators. And for now, we only need value type. So we want to get this one. Then we want to create a generator. And then we do a switch case, and we can do the switch case on this one, yeah. Default. Whatever happens, I always want to have generated or instantiated a generator. So the question is, what do we want to do by default? Maybe an int generator should just be the default. And here we want to get all of these values right. So it's gonna look like get node options by name. Actually, let's take a look here. Float min, but it's going to be an int. Lower bound internal name. Something like this. Okay. Generator cannot be found. I thought we had the correct namespace. Maybe we don't. game creatures generation graph. What is the problem with this not working? Because I'm pretty sure that, yeah, we can do this, and we're gonna get the same error. So generator cannot be found, but if we do dot generator, okay, beautiful. Is it this one then? Let's double check. Never mind. It's random runtime node dot generator. Okay, beautiful. And then we do. I also forgot to fix these. The type of namespace name int generator. Oh yeah. We need to fix those as well and change them to their specific generators. So this one is a float. Vector 2. And we don't have any constructors just yet. Okay. Yes. Fuck, this won't work. We're gonna have to rename these. Yeah. I can just do this, right? Okay, one step closer. And I think we're also gonna need to do serialize reference, and these should be okay, but this one, I'm gonna continue with the very dangerous assumption that this is implemented in a correct way moving forward. And works. Because what I want to do now is I want to introduce this polygon list, which is going to fuck things up. So with none as additional input type, it's nice and straightforward. We take a lower bound, upper bound as input, and we return something else. It's random editor node, so probably a random value between these bounds. But if we choose polygon list here, then this node, this random node, takes a polygon list as input. And when we randomize a value, we want to use this polygon list. It's all going to depend on how many different additional input types we eventually want. If it's just polygon list, then it's going to be, then we can just implement it for each of these generators. One additional input type, sure, but then it's going to get more and more annoying. For sure. I'm second guessing my decision to make this random editor node this. Like maybe we should just have dynamic mesh to transform. And then let random editor node be this, basically. That would mean that we don't need to handle polygon list in the graph and so on and so on. But then again, yeah, polygon list we want to cache. That's why we have it as a separate node. Okay, so yeah. When we talk about this node, we have the additional input type is going to make it way more complicated. And we have one additional thing, like I want to have control over these random generator nodes in my graphs, i.e. I want to be able to set a specific seed. I want to decide when the seed should be stored from backup, loaded, generated again, and so on and so on. Nobro Studio custom node graphs are fun to work on. Yeah, 100% agree with you. I think I've been working with this Unity Graph Toolkit for maybe around 20 hours so far, and it's been quite fun actually. But yes, we're gonna wait with the seeds. They are not that important right now. Probably what we eventually want is, we'll see. I think we will let our creature runtime graph iteration. This one is going to keep track of a seed, and every node that has anything to do with a random seed is going to have that as an additional, or some additional methods, and we send it in or store it or fetch it and whatnot. But okay, as for polygon list, we want to add it in the constructor, I think. So if we call this constructor, number of inputs is going to be equal to 2. But if we have something like this, yeah, that's true. Okay, let's do it like this. I'm still thinking. So currently we have, if we choose polygon list here, we remove the other 2 inputs, which means that I think we're going to get an error when we try and fetch it. That maybe wasn't the smartest decision. What I'm trying to say is, yeah, if we choose polygon list, we don't want to... but maybe we can do it like... So let's implement how I think it should look in random runtime node. I think I want to have a second constructor. Or actually, that is true. We could also... So basically, I think I will want it to look something like this. It's going to be override eventually, but public t generate t, and if we have a polygon list, serialize field, private polygon list, polygon list. Yeah, then we're gonna, yeah, maybe it's better to just send it in. So generate given this polygon list. Then I want it to look like polygon. Let's do it like this. Polygon list get random dot range 0 0 polygon list dot count dot random get random vertex on polygon. Is it actually random vertex we choose? I don't think so. Oh, actually it is. On one sec. Yeah, we do random point. So it's not actually a random vertex, but we do get a, like, the dynamic mesh is built up of, or consists of, a lot of vertices. When we say get random vertex, we don't actually get one of the vertices that makes the mesh. We just get a random vertex on the mesh. But dot random vertex on polygon mesh. So now we have a random vertex. We don't have a random transform just yet, but we can do vertex is equal to this. And then we return, yeah, it's cast and new transform data. V dot position. Yeah, and we want to get the normal as well. We can take a look here how we did it previously. In our old system modules, random position. Vertex. Oh, that's true. But I think we can do, don't we have anything in quaternion like that? So we want a rotation that sets, let's take a look. Let's pull up the documentation. We can do a set look rotation, creates a rotation with a specified forward and upwards direction. And we want up to be our normal and view can just be whatever. So we can do set look rotation, right? And I'm going to do v.normal dot Something tangent, don't we have that? Extensions, vector extensions, generate tangent, what do we need? Game extensions. Dot generate tangent, epsilon mathf, epsilon, and then v dot normal. I thought. And don't we have, oh, this wasn't a static one. Okay, that sucks. Static, static, static. Look rotation. Of course, there we go. And then scale is just gonna be like 1 like this. So this is what I want to do. If we have a polygon list as input, I want to use that polygon list to generate the transform data. When it comes to what we want to do with a polygon list for these, I honestly have no idea yet. So maybe we just do it like this. So now we just need to figure out when to call this one and when to not call it. And how to send in the polygon list. We could send it in, we could actually set it or include it in the generator when we create it. I don't know. Or we send it in after the fact. But then when we generate the value here, we're gonna have to check if we have a polygon list or whatever we have. Or we could yeah, it's definitely not as straightforward how to structure this. I'm starting to think that I might have been a little bit too optimistic trying to pack all of this into one node. And as I said, this with polygon list, it's very specific to this specific use case. So maybe a better idea is to have a polygon to transform. random, or create a random polygon, random transform from polygon list. Or I guess it's polygons to transform. It's a better name. Yeah, I'm starting to think that's what we should do. Yo, what's up, Hypnotic? Thank you for the raid, appreciate it. So on this stream, we're currently exploring Unity Graph Toolkit. So basically, this is how I want to define how my procedurally generated creatures will look. And it's actually pretty straightforward, and we have some good progress. But I'm pretty sure I overextended when implementing this node. Yeah, we're gonna simplify it a bit. We are gonna remove, so polygon list, this node will know nothing about polygon lists. So we're gonna remove this. Number of inputs is always gonna be equal to 2, so we might as well do this. And we're gonna remove this. Let's keep it simple. And if we simplify the runtime node, then we can simplify the editor node by removing this. Yeah. And this. And also this. Okay. To runtime node. This one we keep as it is. Okay, that should be it. And yeah, this means that we're gonna have a lot of very specific nodes. So what we're gonna implement, let's see here, int, float. Okay, beautiful. We're gonna wait with that one, and what I want to implement now is polygons to random transform. Extremely specific node. But let's see here. And then I wonder, should it be... It's going to be random. So it's going to have seeds and stuff like that, which we want to control. I want to put it in procedural, I think. Hypnotic, I'm waiting and running to get some sleep. Totally understandable. Enjoy that sleep, and thank you once again for the raid. Appreciate it, appreciate it. Okay, so this is more like a converter. Here we convert a dynamic mesh to a polygon list. Polygon list to random transform. I guess that's also a converter, but it's also procedural. Okay, I'm gonna name it random transform from polygons. Yeah. Oh, yeah. We also want to add editor node. I don't think we're gonna have any options, not initially at least. On defined ports, it's gonna be extremely simple. Actually, let's do this. Okay, on defined ports, we want to have a polygons input, so we can take the output here and just change it to an input. Add input port, polygon list, polygon's internal name. Yes, and output then should be transform. So I'm just gonna grab this one. Value type 2 string. Yeah, I think we can run with that. Can we do this? Yeah. Is this an option? Yep. So then we have, I thought, okay. Random transform from polygons. We have a little bit of issue with this one. It's not valid character import ID says it's used with subports. I reckon it's this one here. So don't we have no, we don't. Okay. just try and re-add it, see if we still get the same error. Okay, good. So we're going to use this one instead of this one for something as specific as this. Yeah, I think that's okay. Then we can keep this one simpler. Although we're probably going to implement a base random node later on, which this one and this one will use, because the seed handling will be random seed handling will be logic that is shared between a lot of different nodes. But okay. So we have the editor node of this one. Let's see if we can implement the runtime version of it as well. Let's duplicate this one. Input count 1, output count 1. We don't want to have a generator. Is compatible with connection. Ooh, this, yeah, we're gonna keep this one like this. So input count is actually 0 here. And polygons list. Is compatible with connection, input index 0, can output data.primitives.polygon list. That's the input we need, and this one outputs transform data. I think it's as simple as this, actually. Value is equal to t object. We need to get the polygon list as well. That's true. Polygons. Try get input. Yes. And then here we do polygons dot get random range. This, or could we actually just do st instead of this? I thought so. Okay. Here we just return new random, but instead of editor node, it's a runtime node. Generator does not exist. Oh, did I fuck up again? Yeah, I did. Let's take this. Actually, let's take this. Bring it back. Okay. So we generate a dynamic mesh, we slice it, we take the positive one and get polygons from it, depending on, or based on this. And then we get a random transform from those polygons. And then we want to set this random transform on something. So I think we're going to duplicate this one. Game object, yeah. And let's see if we have Richardson I prefab. So we're going to instantiate one of those prefabs. And what we want to do then is, so we instantiate it, then we want to generate a transform for it. And then we want to add child. So hopefully we will get a stone, which we cut in half, basically, or a cube that we cut in half with a Christian I prefab attached to it. But we don't have the node. Let's see. We don't have the node set transform. So we're going to have to fix that one first. Set transform. I think we're going to call it set transform, but we will be able to set. Eventually, it's going to be. It can set the full transform. It can set only position, or it can set. Yeah, it can set various parts of it. I think. Do we have setters? We have alterers, converters, generators, instantiators, procedurals, setters. Okay, add child, set collider, material, mesh. Let's just duplicate this one then and call it set transform editor node. Let's transform runtime node. Okay, I think we're going to do it like this. Set transform editor node will be able to take two different types of inputs. It can be, it should be able to take a quaternion as well. So we're going to be able to decide the input type. It's going to be vector3, quaternion, and transform data. And then it's also going to have some checkboxes if we want to set position, rotation, or scale. Yep. So set transform node. Undefined ports, we're gonna have undefined options as well. I wish it was some simpler way to, maybe there is, I just haven't found it. But I guess we're gonna have to do something like this here as well. Yeah, we're gonna call it value type. Default is gonna be vector3 and delayed, okay. I think that's okay. Display name, we probably want to have vector3, quaternion, and transform. Okay. And then of course we also want a game object, and we're going to put that one as our first. Let's just see, set mesh editor node. Mm-hmm. Set transform, and then I wanted a couple of booleans as well, which we want to put here or after here. Position. Rotation. And scale. Add option bool. Default value going to be true. Okay, nice. Set transform editor node. We can choose the input like this. Eventually, I want the input connection to decide what input it is. I'm not sure if I can fix that currently. And then we can choose which one we want to set. So we could go, we have a vector 3 as input and we set it as position, rotation, and scale. We're gonna have to solve converting it to a quaternion eventually, but yeah. Can it actually solve? I'm skeptical. Maybe. Yes, and we want an output as well. And as for our getters, or every setter we have, we always return whatever we get as input, basically. So let's add that one real quick. Output, output, output. Set mesh. What do we do here? Do we use the same name here? Maybe it works. It's a little bit scary. Probably okay. So input and output port has the same ID, but one is an input port, one is an output port. Okay, nice. And then we can put this one here. The only thing left to do is implementing the runtime of this one. So let's see if we can do that real quick, and then we can try and export it. And if exporting works, we can try and running it. Set transform runtime node, input count 2, output count 1. That's correct. Is compatible with connection. One should be a game object. The other one, however, okay, this is a problem. Maybe not. The other one should be vector 3 or quaternion or Love that they lined up like that. That's beautiful. Or transform data. Okay. Can output a game object? Yes. So try get input here. I guess we are gonna do it like if are we gonna have to define them all here? Probably. So I guess we can do vector 3, vector 3 input, or let's call it input vector 3. This is actually the nicest way we can do this. It feels a little bit weird. And then we do try get input, vector 3, input vector 3, use of unassigned. Yeah, let's see if we need to set that one. And then we do this and do else if. So we just try to fetch all the different inputs, but we should be able to. Yeah. Else return false. And then we try to get quaternion. Let's just call this one vector actually. And finally, transform data. Yes, we have a little bit of we have a few settings we want to have here as well. Set position, private bool set rotation, private bool set scale. So we're gonna have a constructor. One sec. Okay, back, sorry. Let's create this one. And yeah, we want to have bool set position. There we go. This. Yes. 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 Beautiful. Okay. And then we're gonna have if trees for all of these. So if we have a vector 3 and we have if set position, then we do game object transform position is equal to input vector. If we have set rotation, then we do game object transform rotation is equal to Quaternion Euler input vector. And if set scale, can we set, no, that's okay, local scale. I'm okay with that. Nice. And we want to do something similar here. Set position. So how the fuck do we convert? Do we have any, like this doesn't make much sense. Setting position by a quaternion, but maybe we can do something. If I, for some reason, were to build my graph with a quaternion setting position of a game object, what would I expect? Probably not this. Probably not this. You know what? Maybe I would expect up or something like that. Or forward. Maybe. Yeah, okay, maybe. This one normalized. But that doesn't make much sense, does it? Maybe. What's the difference between, what is this? Normalize the quaternion before. Okay, maybe this. Or nah. Yeah, probably. I don't care about angle though. So maybe we can do this. If set position. Angle axis angle was first. We were okay. We needed to normalize this one as well first. And then we do game object. Position is equal to position. Maybe. I'm starting to think, yeah. Okay. And rotation, that's just this one. Nice and easy. And scale, I think we would do this. Normalized. Like, this is weird. If set position or set scale is set as true for a input of quaternion, I think this is like the best case scenario we can do with that setup. And finally, transform data. This one is probably the one that is most straightforward, because here we just have position, rotation, scale. And that's it. That is it for this one. I think I only need to convert it to runtime to runtime node as well. Yeah, here we want to change this one to set transform runtime node, but then we want to fetch a couple of booleans as well. Set position, set rotation, set scale. Like this, I think. Interesting. Have I forgotten to serialize anything? Random transform polygons. I don't think so. Let's save it and see if it exports. Okay, everything seems to be exporting the correct way. Okay, great. Let's see if we can play it then. See if we can generate something with this. Okay, a little bit of a cliffhanger. I'm going to try it soon. So let's see here. We generate a cube dynamic mesh. We slice it based on this plane. We just take the positive result and instantiate a new game object, convert it to a mesh, convert it to bounds, set mesh, set collider, set material. And we also take it, convert it to polygons with angle threshold 15, that's okay. And then we convert this to a transform. We instantiate a creatures TNI prefab, set the transform, set everything. And then we add it as a child, and then we create a creature out of it, or add a creature component, yes. Let's see. Okay. We do get our eye here. Thought I had to change this material. Okay. We get this one at least. And we get this one with a collider and everything. So, specified cast is not available. This sucks. Random transform from polygons. Let's see here. It's generate the new dynamic mesh to polygons runtime node. So I guess this one works. This one seems to not work. Okay. Wait, this log doesn't seem to be in the correct order, does it? Failed to generate random transform from polygons. Okay. Can't output Unity Engine Vector 3. Yes. So I guess it fails at here, right? Oh, have I been... Yeah, maybe I fucked up here. Because try get input. Return... I don't know. Yeah. Okay. Yeah, it outputs this, but it didn't really fail. We're gonna have to clean up that log message. So we return false here, but then we continue to quaternion. Didn't we get one for quaternion? That's weird, if that's the case. No, we didn't. Because I would think that if this one fails, we try this one. But this one fails as well. And then we try this one, but it succeeds. But in this case, it just looks like we continued. Right? We only got one fail as well. What am I missing? Yes, okay, I get it. Okay, so we can't do it this way because when we try and get input... Oh, you know what? Maybe we can, but we need to fix something, yeah. Yeah, what the fuck? Yeah, what the fuck? Return false. This should be it, I think. Oops, should have quit before we recompile this. Because we don't return. If it fails to fetch it, it continues on, but without it. And then when we generate the output, this one returns false. But we want to return here and try some other output, okay? I'm gonna re-export this one just to make sure, and then we're gonna play. Still get an error. Is it the same? Let's see here. I want to see failed to generate. Okay, here we have failed to generate. So we try to get another output, failed to generate. So we try to get another output, and that one succeeds. But then we have a similar issue. Random transform from polygons. Yeah, what the Okay, so we return a vertex here. We need to vertex v is equal to get and get random vertex, and then we do transform data. Forward should be normal. Yeah, we can just do this, right? V dot normal. And so now we have transform data, and it's this one we want to cast to whatever type we're asking for. We're asking for transform data. Okay, let's try this then. Rebuilding to make sure, although we shouldn't need to. And now we don't get an error at all. The transform of the eye is a little bit off though, to say the least. It's a child, all right, that's good. But it's located, I have no idea why it's located here. I want to try one thing. We're going to go to this one and add additional editor node, keep child world position false. Let's try that. Save. Play. Is there ever a case where we get another rotation on this one? Doesn't seem like it. No, rotation is always 0, 0, 0. Okay. Then I want to check dynamic mesh to polygons. I'm very interested in a polygon list, or more specifically, I'm interested in a transform data. Can we do this? Or actually, I already have the transform data. That's true. Let's see. Okay. The transform data we already have, because I think I don't care about scale. This one and dynamic mesh to transform. Yeah, this one we don't work with, but this one we do. I'm gonna do a log here where we just do polygon list of size. Okay. Let's start with polygon list of size 13. Do we have 13 polygons here? I would think that we would be having 13 polygons. That's wrong. Well, have I screwed up this one? I think we should have 1, 2, 3, 4, 5, 6 polygons. In fact, we get 13. Now, that's a good question. We can see here that our transform data, yeah, ooh, we... Hmm. 13. Do we get all triangles? Nah, that's more than 13, isn't it? So here we have 8, 9, 10, 11. Yeah, way more than 13. I did so thorough testing on this one. 15. Let's just see if we can find a dynamic mesh to polygons. Let's see if we can find some error here. Dynamic mesh.get polygons angle threshold. Here we do a flood fill and we do it with angle threshold in degrees. It's 15 degrees. So if the difference between triangles are less than this one, then we add them in the same group. Yeah, I don't want to debug this one right now. This one should be fine. But yeah, apparently it's not, because we get 13 polygons. I want to try, let's just see what happens if we do, let's alter, or actually, let's check angle threshold 15. We send it in here. Oh. Should be okay. Yeah, let's try and alter this one to, let's start with 0 and then something high. Okay, 13 if we have 15, or 0, I mean. Let's do 50. Still 13. Okay. Yeah, I guess I'm gonna have to start tomorrow, or I won't be able to stream tomorrow, I think, but I think I'm gonna have to start Thursday stream with debugging. Like, is it possible that this one fails? There must be something I'm overseeing. We're gonna do one more test here. We're not gonna slice it. So instead we just take dynamic mesh here. Oops. And here. So we skip the slicing. I don't think I need to do this, but let's just to make sure. Okay, so let's not slice it and see what happens. Yeah, we get a little bit of a bigger cube. The polygon, now we get the correct polygon list. So I wonder what I fucked up with slicing. The position of the transform data is still fucked, but that might be because of this one. Let's try with that one and play. Okay. Okay, so we have two things to fix. Slicing screws up the polygons for some reason. I think it's the normals, maybe. And this one still doesn't get the correct position or whatever. Yeah, or rotation. Okay, I'm not sure if I can stream tomorrow. We'll post on Discord if I do. Otherwise, we'll continue this on Thursday because I gotta run. Still good progress today. I'm happy. Thank you so much for watching, everybody, and have a great rest of the day. Peace.